Hi folks, this is Mundan Raghavan. In today's video, we are going to slices in Go language. In previous video, we have seen what is array and how it works. So slices is just like a subset of arrays that we are going to discuss in this video. Before starting anything else, we will just understand the definition about the slices. Actually, array we have seen it has the fixed size. That means that once you created the array, you cannot change the size. But however, it is not very dynamic or flexible for the end user. For that reason, Go language has another concept called slice. That means that the slice, it can increase its size dynamically when the requirement needs or when you open some more elements beyond its limit. So that's why it is called slice. So as you see here, it is a dynamically sized and flexible to the elements of an array. In general, you can create a slice by using the underlying array. Generally, array will be the underlying set and you will be getting the slices over the array. And slices is nothing but it's just like a pointer to your array. In case if you go beyond the limit, it will just create one more array and you will be copying the elements from the older array to the new array, which will have the higher capacity when compared to the previous one. So generally that's what here definition also tells. A slice does not store any data. It is just describe the section of the underlying array. Generally array will be starting like square brackets and then the type of the array. In case of array, in case of slices, we will be having the square brackets and the type of the slice. But in case of array, we had a square bracket. Inside that we will have the length of that or capacity, right? So here we don't have anything. So we can directly create with empty square brackets and the type of that. Now we will see some of the main functions inside the slices and we will compare with the arrays. First, we will create the slices from the arrays. In order to get the slices from the arrays, I am creating the arrays here. For example, ARR and shorthand notation, I'm using 5 elements type of integer and I'm giving directly the declaration and the initialization directly here, which means that it will have the elements 1, 2, 3, 4, 5 and I'm printing that as it is. Then I'm creating the slice. So slice generally starts with, let's say, colon symbol. That means that whenever you create an array, by using the slicing operator, which means that's a colon operator, you can just slice the array and you can assign it to the slice. Slicing in the sense you are going to provide the starting position and ending position. Whatever the position you are providing as a end, that will be excluded. Actually, it means that you are going to slice the array, so ARR, and after that you have the square brackets and you are mentioning the starting position. That means that index 1 to index 4. But index 4 will be excluded. That means that index 1, index 2 and index 3 will be included. And that will be saved into the variable called S and I am printing the S. Let's see what happens with this. Now you can clearly see the first one we are displaying the array and after when I create the slice out of the array, it is showing only the index 1 to 3. That means that excluding the 4, it is showing till 3. That means that 1, 2, 3. That means that the values will be respectively 2, 3 and 4. So this is the way you can create the arrays. So you can create the slices from the arrays. Now let's say what are the different other methods available in this. So let's say since we have created the slices, we can see the main two methods which are available for the slices, which is nothing but one is length, another one is capacity. So just we will move this pointer so that we can see till which point we have seen the output. Let's say save it and execute again. Here you can see the length is equal to the how many elements you have inside this slice, that will be equal to your length, and capacity will be something 4. Now don't worry about the capacity, but the capacity is the maximum thing that you can put it into the slice. But in case if you are going beyond this limit, then it will create one more array and the pointer will be moved to the new array. That we don't need to worry. In the backend, Go language will take care. In simple words, if you are going with slice, you don't need to worry about the size. Just it will increase whenever you are going beyond the limits or capacity. Okay, fine. That we will see in the last time and we will see here. So length and capacity. Length will give the current length of the slice and capacity will give till which point it has the capacity as of now. When you go beyond this capacity, it will increase by itself. That we will see in the later stage. Now slice is a type of reference. In case of array, we have seen it is a type of value. That means that if you are copying or if you are assigning to the another variable, the copy of the value will be just pasted there. That means that when you make changes in the copied version, it will not reflect in the actual version. But in case of slice, it's the reference. That means that array is the underlying data structure where you will make the slices over the array. So how many arrays you make it, or which position you make the slices out of the array, it is just a reference to the underlying array. That means that whenever you make changes of the slice, it will directly reflect in the array. Let's see. Now, as of now, we have seen the array. It has 1, 2, 3, 4, 5, and we have the length and capacity we have seen. Now I'm just changing the slice first index. That means that in the slice, I'm going to change the first index to 888. But however, the slice is taken from the array. So what are the changes inside the slice and what are the changes inside the array that we will see? Just one more time, I will add this splitter so that we can see block by block. Here you can see initially the array has 1, 2, 3, 4, 5, and we made the changes by making the slice 2, 3, 4, which has the variable called s. Then we have seen the length and capacity respectively. And in the slice, I'm first changing the value 2 to the 888. So that means that index of slice 0 will be changed to 888. But when you print the array again, the underlying data structure itself changes. That's why you are seeing the second element, which is nothing but 888 has updated here. Right. So in this way, you can clearly understand slice is a type of reference. So whenever you make the changes in the slice, it will directly impact the array, underlying array. Okay, fine. So when you make the slices, we have already seen we are giving the initial position and the ending position, but ending position will be excluded. So in that case, what are the default values? Let's say if you are not giving any values, how it works, that we are going to see here. Let's see here. So the last block we are going to see. So whenever you don't give any values for the starting and ending both together, that means that by default, it will take from the initial index of the array and it will be taking the last element till the last element of the array. Then if you are giving directly, if you are giving without any values, it is equivalent to this time because the initial array will be having the elements of, let's say 1, 2, 3, 4, 5, which is size of 5. So that's why you are giving, let's say 0 to 5. You may wonder here, it's like index starts from 0 and end position is 4 actually. But as you already discussed, the ending position will be excluded. In order to get the fourth position, you need to give 4 plus 1. That means that 5. So 5 will be excluded till fourth position, it will be taken. And then after, if you don't give the initial position, it will be taken from the initial, that means at 0 index, and it will take whatever the values you are going as an end value. Or if you are giving only the starting position, if you don't give the ending position, still it will get the till the end element of that array. Let's see what are the things we are going to see here. Let's execute again. Here you can see everything gives the same result. That means that even if you don't give anything, it will take from starting to ending. If you are giving starting to ending, you will be giving something like the end value will be excluding the end index, right? And after that, if you don't give the starting index, it will be taken from the starting by default. If you are not giving anything to the end index, it will be taking till the end element of the array. So this is the way the slicing will be working with the slice operator. Okay, fine. Then is it possible to create the slice without any size or without any values? That is possible, but however, it will be considered as a nil array or nil slice. Let's see this. So in this, the variable name is 0 slice. And after that, I'm giving the square brackets without any value. That means that it is a slice type of int. And I am just initializing without any values with empty braces. So that means that it does not have anything. So when you try to create it, it will not give any error. It will create the slice with 0 length and 0 capacity, which will be considered as a nil. Let's execute this one and see. Before that, I will just make the one more divider so that you can see the last block. Okay, fine. Let's execute. And you can see you are creating the 0 slice, but it has the 0 length and 0 capacity, which does not make any sense. Actually, it is a nil array. So in that case, you can directly check whether it is nil or not. Based on that, you can do the programming logic. Okay, fine. So now we will go to the dynamic array. So rather than executing everything again, we will just comment everything so that we can look into the what are the things we are going to see again. So great. So now we will be seeing only these things. So next one is dynamically sized arrays. So that means that you can create the slices by using the underlying array by making the slice operator. But however, there is another method inside the Go language. Directly you can create the dynamically sized arrays, or you can create the slices directly. So let's see how it works. By using the make method, you will be giving the type of slice and you will be giving the length and capacity. But capacity is optional. You can give the capacity or you can give only the length. So let's say first we are going to create one int slice. Then we are giving the length of 5. And we will just print the length and capacity, and we will print the array. Sorry, we will print the slice itself. Okay, let's clear the screen and execute again. Before that, I will save the file. Okay, fine, execute. Now you can see it has created the array with length of 5. Since the length is 5, the capacity also initially made it as 5. Then after, since we have not given any values to that slices, it is just giving the default 0 values, which is nothing but in case of int, it is zeros. Okay, fine. When you give the capacity, what happens? Let's see that one as well. So here what happens is just I will make this one as a command, and I will one more time create the new variable by using the shorthand notation. Now here I am creating the int slice with having the initial length as 5, and after that it will be having the capacity of 10. Then I will be printing the array itself. Let's execute and see what happens. So in this way, clearly you can see, even though the length is 5, it has only the 5 elements inside that with the 0 values of int, but it has the capacity of 10. That means that still you can append to this array, or you can append to the slice, which internally updates the underlying the array, which has the capacity of 10. So in runtime, you don't need to just look for any other things. You can directly add the values to that. It will be very good till the point you reaches the 10. After reaching the 10, it has to create the new array, and it has to copy all the old elements of the array. It has to put it into the new array. That we don't need to worry, because the Go language will take care. Okay, fine. So the next one is, let's say append method. It's a very important method. So that means that you already have the slice and you are going to append to that slice. So what happens with that? Let's consider here you have created the slice having the length of 5 and a capacity of 10. So whenever you see the length and capacity, that means that you are dealing with a slice, because in case of arrays, you have only the size of the array. You don't have anything called the length, or let's say capacity actually, to be precise. It can have the length, but it will not have the capacity in case of arrays. But in case of slices, you will have both length and capacity. Let's say we have created the slice, which is having the length 5 and the capacity as 10. Then after, I am just appending 2 more values. So initially it had 5 values, and I am appending 2 more values. Then first argument will be your the base slice, and after that I am adding the things which I need to append with that slice. And I'm just assigning back to the same variable d. Then I will be just printing the length and capacity. I'm printing the total array. Here you can see the length has been increased from 5 to 7, but still the capacity remains same 10, because we have not crossed the 10. So the capacity remains 10. But however, the data structure or the slice, you can see initially it had only the 5 zeros. In later point, since we appended 2 values 22 and 33, it has the 22 and 33 at the end. So in this way, you are just appending to the existing slice, provided you have the enough capacity. What happens if you don't have the enough capacity, but still you are trying to append that one? So that's where the benefit of the slice comes into picture. Why? Because if you have the same array, and if you are just playing till the array size, that you can directly use the array itself, because however you are just going to use the array within the limit. But in the runtime, if you are going beyond the limit, in case of array, you will be getting the error because it is going beyond the limit, right? But in case of slices, it will automatically increase the size for you. It will increase the capacity for you. So that's what the general codes or general definition about the slices. For example, here you can see, however, if there is not sufficient capacity, a new slice is created. All of the existing elements are copied over. The new element is added onto the end. And new slice is returned. So this is the way it will be working. Okay, fine. So let's create the array, not array actually, the slice. Here we're making the slice with the int type, and it has the the length of 2 and the capacity of 5. So since I'm giving the length of 2, I'm giving just 10 and 20, but still it has the capacity of 5. That means that still you can add 3 more elements to the slices. Then I'm printing the slice as it is. Then I'm printing the capacity and the length of the existing slice, which is nothing but the slice. Then what happens is, let's say if I'm trying to add the elements which is exceeding the capacity of the slice. Currently the capacity is 5 and it has the already 2 elements. So that means that we have only 3 elements more, but I'm adding some more elements which is greater than the 3. So in that case, what happens is it will append that and the capacity will change automatically by the Go language. Here you can see the first one, the slice array I'm just printing. It is having only the 10 and 20 and length is 2 and capacity is 5 as we created here, right? And slice here, after appending the data, it has appended every data from 10, 20, then after 30, 40, 50, 60, 70, 80, 90, right? It has appended all the data. But however, when you see the length, it is 9, which is beyond the 5, and capacity is increased to 10. That means that the capacity was increased from 5 to 10, double the time. So whenever it crosses its limits or capacity, it will increase the capacity double the amount what it has. For example, in our case, it has 5, it just increased to the 10. So this is the way the slice will increase its size. So it makes a dynamic increment for the user so that the user don't need to worry about the size of the slice. So this is some of the very basic things about the slice. However, we have the different ways how to insert, or we have seen already append, how to append, or let's say how to delete some elements by using the slice, or you can iterate through the for loops. Once we have just understood the for loop, then we can see about how it works inside the for loops for the slices. And the same way you can send the slices from one method to another method as argument as well. But however, it is just like an introduction session about the slices. The basic point we have seen. However, slice does not save any data. It is just like a pointer to the underlying array. The array will have only the size, but in case of slices, you will have the length and capacity. Capacity will be automatically increased whenever you are crossing the capacity. It will double the capacity. And older elements will be copied to the new slices, and you will be getting the new slice as a return value. So those things, it will be taken care inside the append method. So this is where you are seeing the encapsulation. That means that encapsulation and the data abstraction. That means that whatever the things happening inside the append method, you are not going to see here. And whatever the code you have written, that is encapsulated inside the append. But however, it is not a oops concept. It is just understanding point I am telling. So thanks all. Thanks for watching. Have a great day.